All right. So now we have done with how to solve second order differential equation. So for this chapter in your coverage, the application is up to second order, right? We don't have the application up to fourth order. We just know how to solve up to fourth order for the homogeneous part. Okay, we have done with solving the homogeneous equation for first order, second order, third order, and fourth order. And all of you know how to find the solution of particular integral, okay, by using both method of undetermined coefficient and also method of variation of parameters. So that is all about in chapter 2, all right? We just learn about the homogeneous, non-homogeneous, finding the solution, applying the condition, okay? By looking at the value of constant there, you can solve by using the condition given. Okay, and then now, where can we apply those fundamental? Okay, so as for today, I'm going to briefly explain about the application of second order, and then I'm going to give you in terms of assignment after this. So our assignment should focus on this chapter. All right. Okay. So now, shall we start?
Yes, okay.
We have how many participants? 36. Okay, it's okay. All right, so now the application of second order. So one of the application is mechanical vibration. Okay, in mechanical vibration, there are 4 types here. The undamped free vibration. All right, so this is mechanical vibration where you have K, M, F, B. M is mass, F is force, K and B is constant there. All right, sorry, B is damping coefficient. Okay, now the general form of this mechanical vibration is given by this. So this is the general form of my double prime plus by prime plus q equals to ft. So this is the general form of mechanical vibration represented by second order differential equation. So we are going to find what is our solution, which is y. Okay, in order to get this, in order to solve these 4 problems. So what are the problems? Okay, there are 4 types of vibration, okay, which are, the first one is undamped. Undamped free vibration means there is no damping and no vibration. So when there is no damping and no vibration means that there is no damping coefficient. There is no B, right? Because B is damping coefficient. Okay, and then we just have here my double prime plus ky equals to 0. Okay, understand? No damping means no force. So that's why it is 0 there. No damping means no force because that's why that is 0. Okay, so this is how can you explain about your problem that you're going to discuss. What is the definition? What can be described from the equation, right? And then what can you find from the equation? What you need to solve, okay? Then that's why this is homogeneous equation. Why it is homogeneous? Because there is no force involved. Why? Because which results to no damping. Okay, so this is the first type of vibration, undamped free vibration. The second type is damped free vibration. We have damping, but we have no vibration. Okay, so we have damping, so we have B, no vibration, also no force. Then that's why the right hand side part is 0. Okay, then the next one, undamped force vibration. No damping, but involved with vibration, with force. So that's why we have the non-homogeneous equation. My double prime plus ky equals to ft. And the last one, damped force vibration. Okay, means all elements involved. It is damped with a vibration, okay, with a force vibration. So force involved, damped involved. Then this is just the non-homogeneous where all the coefficients are all involved. So these 4 equations of types of vibration can be solved by using the second order differential equation which you have learned previously. All right. How can we solve it? Of course, we need to identify it is homogeneous or non-homogeneous. And of course, you start with finding YH by changing to characteristic equation and then convert to quadratic and solve the quadratic equation, right? And after that, you identify what are the types of the roots involved. If it is real or distinct, real or equal, and then complex, what should be the solution? So those are applied here. Okay, what you have learned previously are applied here. So you want to solve this kind of mechanical vibration, which is subject to the condition given. So when t is 0, okay, all right, the function here is in terms of t, it involves time, okay. When t is 0, y0 equals to alpha, let's say alpha, maybe it can be in terms of a value here. So theoretically, this alpha is initial displacement. So usually initial displacement is 0, right? Because when time is 0, there is no movement, there is no displacement, then initial displacement is 0. And y prime 0 equals to velocity, v, initial velocity. So the upward is stand for the negative sign, the downward is stand for positive sign. How can you identify this? By what? By pulling the spring. If you pull the spring upward, then it will be in terms of a negative sign. If you pull the spring downward, then it can be in terms of a positive sign. Okay? And we want to solve y. Okay? This is your differential equation. Right? This is your differential equation. And of course, by solving this, you will get y. So we solve y for a displacement of the spring at time t. Right? So you pull the spring and then you want to evaluate what is the displacement of yt at time t. Right? Is that clear? This is the whole story of this mechanical vibration. Clear or not? So just like, okay, let's take a look at the example. But I'm not going to discuss everything here. I'm just brief to you because after this you're going to use the assignment. Okay. Now look at this example. The response of an overdamped system to constant force is governed by the equation. So for this kind of example, you have the equation. Okay, you just find the solution, right? Just like we did in our previous lesson. You are given an equation, you know that it is a second order, you find the solution. But this equation is represented by an overdamped system to a constant force, where that's why it is constant here. And damped system, that's why there is a coefficient of dy dt, because that b stands with y prime because b is damping coefficient there. Okay, so you just solve this. Compute the displacement, find yt, and what happens when t approach infinity. So once you find your yt, so how can you find your yt? Yt, solve the differential equation. Once you obtain your yt, just substitute t is infinity to your equation. And then what happened to your y? That is the meaning by what happened when t approach to infinity. Okay? All right, next. So this one is given in terms of a problem. So you need to understand. Okay, a 3 kilogram object is attached to spring and it stretched the spring 392 mm by itself. There is no damping and a force function is given. Okay, the object is initially displaced 20 cm downward from its equilibrium position and given an initial velocity upward. Okay, so you know what is the meaning by downward, what is the meaning by upward, and you know that this is no damping system with a force. So which one? Undamped with a force. So this is, okay? So you know which item refer to which types. And then write down the governing equation. So this is how you do it. And find the displacements. Just solve the system. Okay? This is how you do it. A 3 kilogram object. This is M. Identify what are the information given. Stretch the spring. So this is what? 392 mm by itself. There is no damping in the system and the force function. This is Ft. So you know that this is undamped vibration system. Okay, undamped force vibration where my double prime plus ky equals to Ft. So you know that it follow y double prime plus ky equals to Ft. Okay, so what is M? M is 3 kilo. So this is your M. What is K? K is spring. What? K is spring constant. How can we find the spring constant? Is given by this. K equals to mg over L. M is mass, G is gravity, where L is a length of a stretch spring, which is 392 mm. Okay. All right. Usually in our calculation, you have to refer to the units given. So this is kilogram, this is meter. All right. Then just change these to meter. So that's why L is 0.392. So just substitute. Okay. Once you obtain your equation and you know how to do next. All right. Clear or not? Any question? Okay. So you identify what are the types of vibration and identify the information. Then once you got the equation, of course, you know how to solve it. Okay, referring to what we have learned previously. Finding H, finding YP, and this is YP for particular integral. You can use method of undetermined coefficient because this is cosine. Right, and then apply the initial condition given and then the solution is given. So what are the condition given? So given here, the object is initially displaced 20 cm downward. Okay, remember, downward is a positive sign. Upward is negative sign. So that's why here. Okay. Initially, so initial position of course T at 0. It is position 20 centimeter downward, change it to meter, so positive 0.2. Okay, and then for velocity, initial velocity at time 0, okay, it is positioned at 10 centimeter per second squared upward, so negative 0.1. So once you have the equation, the condition, you can solve the system. Okay. All right. So that is mechanical vibration. Okay. We have 4 problems in solving the types of vibration here in mechanical vibration. So 4 problem means 4 group. Okay, you can solve it in a group after this. Okay, next, what are the application? Okay, RLC circuit. Okay, this is RLC circuit where it involves VI, RLC, and Q. What are those? So V is the voltage, I is the current, R is the resistance, L is inductance, C is the capacitance, and Q is the charge across the capacitor. Okay, so the governing equation for RLC circuit is given. So this is the equation for RLC circuit. And you know that I, current here, is dq dt. Okay, the change of charge across the capacity within time. Okay, so our aim is to determine I or the charge Q or both. So two methods. Okay, so there are two methods to solve RLC circuit problem. First, solve in Q. Second, solve in I. So here, if you want to solve in I, means that what? I here. I can solve by using I is dq dt. Okay, in solving I, you can solve by using first order. Here, this is just a linear, right? In solve in Q, where I equals to dq dt. Okay, so di dt is d squared u, d squared q dt squared. So you need to solve the second order. Okay, let's understand the problem. For discussion, let us consider the following problem. So this is just a discussion. The series RLC circuit has a voltage source by ET equals to 100 V. So ET is given. This is the function of ET. Okay. A resistor R, 20 ohm. So R here is a 20, is a constant coefficient of I here, and inductor L equals to 10 H. Where is L? L is here. Alright. And the capacitor C equals to 1/6260. So what is C? C is here. If the initial current and the initial charge on the capacitor are both 0, then determine the current I and the charge Q in the circuit for t greater than 0. So we have two methods, solve in terms of Q or solve in terms of I. Okay, so let's discuss this together. So now, you know that this is your RLC circuit. Okay, you have the problem with L equals to 10, R equals to 20, ET equals to 100, C is to 1/6260. And initial condition is given. At time 0, I is 0 and Q is 0. Okay, so substituting every information here to the governing equation here will give you this. So 10 the IDT plus 20I plus 6260Q equals to 100. Right? Okay, now we want to solve the problem in Q term. So how? So you know that this is the IDT. Okay, we want to identify Q. So I is given by dq dt. Then d IDT is d squared u dt squared. So you just replace this di dt with d squared u dt squared. So I is dq dt, then di dt is, we just again differentiate dq dt. So that's why we have d squared u dt squared. And I here is dq dt. Okay, q is q equals to 100. So as you can see, if you simplify this by dividing with 10, then the equation will become like this. And how can we solve this kind of equation? What is the form of this equation? D squared u dt squared plus 2 dq dt plus 6 to 6q equals to 10. What is the form of this? Anyone? No one? Linear non-homogeneous. This is second order, right? This is second order, linear second order, and non-homogeneous. We have function, right hand side function ft equals to 10. So if you want to use method of undetermined coefficient, so your yp should be constant, right? So this one, you just solve the second order differential equation, okay, directly, just like we did earlier. Okay, So how can we find the solution? Of course, you have to change to characteristic equation, convert this to characteristic equation, find M, identify the types of roots and the solution for QH. Since we use Q here, then it is QH. Okay, find QP. You know that your function is 10, then the YP, the QP is a constant. Check the similarity. So it is actually QP T to the power of R C naught. So check when R equals to 0, QP equals to C naught. Check with the QH. Is there any similar term? No similar term. Then this is your QP. And identify C naught by matching with the differential equation. Right, and then substitute and find C naught. C naught is here, and then the last solution is QT equals to QH plus QP. Just combine both equations. Okay, then what? We have the constant, we have the condition, then we can find the values of constant A and B here. Apply the condition, Q naught goes to 0. Another one is what? What is another condition? That the initial current and the initial charge on the capacity are both 0. So we have Q naught equals to 0, and then you can find A, okay? And then initial charge I0 equals to 0, but we don't have I. So remember I is dq dt, then we just have Q prime 0 equals to 0. So you have to differentiate, apply the condition, and we can find B. So once you obtain A and B, substitute, and this is your governing equation for QT, the solution for Q. Okay, clear now? Then from this Q, you can find I. We have our Q, we have our I. How can you find I? I is dq dt. Okay, clear? Just differentiate. All right, so this is how can we solve the RLC circuit by using Q term. Okay, now let's try to solve the problem in I term. Okay. All right, so as you can see here, this one, directly see, then we know that it is a linear, the linear differential equation, first order, right? Because we have the IDT, I. But we have Q here, and Q is actually di dt. Okay, so now substitute all the information given, and this is the condition. Therefore, the function here become like this. Then R is what? R is 20i, Q is 6260. Sorry, C is 1 over 6260. Q equals. So we cannot solve this directly because we involve both I and Q within time. So you know that Q is di dt, then you just differentiate Q here with di dt. So in order to standardize the equation, we should differentiate all them. So differentiate this, will give you d squared I dt squared. Differentiate I, you get the I dt. Not differentiate Q is the differentiate Q is dq dt, where dq dt is I. So now it is simplified to this. Okay. So initially it is L di dt plus Ri plus Q over C equals to Et. Okay. And then after you substitute all the constants given, then the equation is in terms of I and Q altogether. So you know that Q is di dt. Then what we do here is to differentiate. Okay, differentiate the IDT will give you the squared IDT squared. Differentiate I will give you the IDT. Differentiate Q will give you the QDT, which is what? Which is I. And differentiate 100 equals to 0. Oh, sorry. Terbalik. I equals to the QDT. Okay. So now you have second order of I and T term. So in solving this second order, you are going to have the solution in terms of I. All right. So you just proceed with finding IH. Right. And this is homogeneous. Then just proceed with IH only. Okay. So if this one is 0, right? If ET is not constant, then the second equation here, this equation here will become non-homogeneous. So just solve how non-homogeneous can be solved. Just use method of undetermined coefficient or MVP method. All right. So the process is similar with what we did earlier. But the problem is how you want to reduce from a problem to an equation. All right. Once you obtain the equation and the equation is correct, then you just can solve the equation basically based on what we have learned previously. Okay. Second order, homogeneous or non-homogeneous, MVP or method of undetermined coefficient. All right. Same. Okay. Then this one, you change this to characteristic equation, identify roots, and identify the solution. So this is your I. Okay, in order to determine A and B, apply the condition. The condition given is I0 equals to 0, right? And we have Q0 equals to 0, but we don't have the equation Q. Okay, so now evaluate the equation at T equals to 0. So what we did? Just substitute T here with 0. So just substitute here. Q0 is 0. Okay? Or we just can differentiate. Same. All right. Then apply the condition and find the constant again. Substitute to the constant. And remember, I equals to dq dt. And in order to find q, you just have to integrate I. You obtain the solution for I. This is the solution for I. This one. Right. So in order to get q, you just integrate I. Okay. Clear or not? So this is how you obtain q. All right. Clear, everyone? Okay, good. Can you see it here? What I am sharing? What is the file I am sharing here? Assignment, all right. Okay, so now I have briefly explained about what are the application in second order differential equation. So now, okay, now there are several applications. So let's discuss this assignment. There are several applications that we have discussed earlier, okay, of second order. So this assignment is focused on second order. Okay, so what you need to do is, after this, I'm going to clarify this assignment in a detailed version. So this is just a brief explanation, all right? So what you need to do is to explain what is the problem that you are going to choose. Let's say you choose damped vibration. So you have to explain, summarize by the topics that we have learned in terms of second order, Okay, types of second order, what are the solution involved, and what is the problem that you choose. And then give the example that you choose. So give one example and describe the calculation of the application. So what you should do is to compile it in a report and video and upload it in e-learning in the submissions button. So later I'm going to open the submission button in your e-learning. Okay, so remember this piece of work counts for 10% of the assessment for the course and must be handed in letters by 31st May 2022, which is on Tuesday. Okay, on Tuesday, 31st May 2022, which is after Hari Raya. Okay, and you should work in a group of 4 or 5, but this class, I think it is about 53, right? Is it 53 students? Let me check. We have 54. Okay, so we have 54 and we have 6 topics, all right? Dampened vibration for types, RLC 2 types, so 6 topics. So 54 divided by 6, one group, 9 each. It's quite a lot, but it's okay. Okay, so you should work in a group. Only the group leader should submit the work. Okay, and don't submit the video. Just provide a link in terms of Google Drive or YouTube and compile it in a report. Okay, so what you should submit is a report which is attached by the link of your video. Okay, so group mark will be awarded based on the clarity of the report presentation, clear explanation of the solution, method, language, flow of ideas, and quality of solution obtained. Graphical illustration and coding language should give you an extra mark. Okay, so these are the rubrics. All right, so any question? So I have done explain with the application and also the assignment. So now I am open for any question.